couple other little things about point clouds. One is the point clouds, of course, are sampled from the surface that this depth sensor hits. So what you're getting is you're getting a sampling of the surfaces, which means there are no volumes. You have to infer a volume, right? So even if there's a nice sphere right here, you're going to get points along its surface. And maybe if you move around, you'll get more points from the surface, but it's up to further processing to decide, oh, that's this spherical volume. So there's no explicit representation of volumes. There is an interesting element to it, and that has to do with surface normals. So I assume you all know what a surface normal is. You've got geometry. So the idea is you've got some underlying surface, and at any given point you could fit the tangent plane, and the normal to that plane, that's referred to as the surface normal. That you can think of it as a first-order local approximation to the surface. Point clouds actually have surface normals. And you might ask, how is that possible?
How is that possible?
Well, because the sensor, it does a variety of little processing to try to find the little local points nearby and fit that tangent plane in order to estimate the surface normal. And sometimes that's useful. I will tell you that the surface normal representation is less robust than the actual location of the point itself. So this cute little needle diagram, in order to fit them, you have to essentially take a little Gaussian around the points that are there, fit a little tangent plane to those Gaussian weighted points, and then that gives you an estimate of the surface normal. You have to figure out how big a Gaussian do you want to use is a little bit like how big a Gaussian do we use when we take an image gradient. Remember that? We used to have to smooth out the image to get rid of the noise, but the more you smooth it, the more you've spread out the gradient. Same thing is true here. The more points you consider, the more smoothly the surface normal will vary.